Hello and welcome to this lesson on the structure and properties of fullerenes. In today's lesson, we will explain the structure of fullerenes, including the incorporation of hexagonal, pentagonal, and heptagonal rings. We will then focus on the significance of Buckminsterfullerene before discussing the properties and uses of fullerenes due to their structure. Previously, we have discussed the carbon allotropes, diamond, graphite, and graphene. Today, we will introduce another fascinating allotrope, fullerene. Fullerenes are molecules composed entirely of carbon atoms arranged in hollow, cage-like structures. Unlike simple flat sheets of carbon atoms as in graphene, fullerenes have a three-dimensional shape. The fundamental structure of fullerenes consists of interconnected hexagonal rings of carbon atoms, much like a honeycomb. Now, in fullerenes, this hexagonal pattern can be distorted by incorporating other types of rings, specifically pentagonal rings with 5 carbon atoms and heptagonal rings with 7 carbon atoms. These additional rings help the molecule to curve and close the structure. They introduce kinks, or bends into the structure, allowing the plane to wrap up into a closed hollow sphere, leading to a variety of shapes and sizes. An excellent example of such a structure is Buckminsterfullerene, or C60, the first fullerene to be discovered. It's commonly referred to as a buckyball, as it looks quite similar to a football. Buckminsterfullerene, C60, consists of 60 carbon atoms arranged in a ball, with 12 pentagonal and 20 hexagonal rings. Each carbon atom in C60 forms 3 bonds, just like in graphite or graphene, but the presence of pentagons causes the sheet to round up into a sphere. This spherical arrangement influences the properties of C60 and other fullerenes significantly. Because of their hollow shape, a fullerene can trap other atoms and molecules inside it. This unique property is useful in numerous contexts. For example, fullerenes can be used for drug delivery in medicine. By carrying drugs directly to targeted cells, such as cancer cells, fullerenes can make treatments more effective and reduce side effects. Another important property of fullerenes is their huge surface area. The large surface area of fullerenes, combined with their ability to bind and release various atoms and molecules, makes them excellent catalysts, speeding up chemical reactions without being used up themselves. This property is particularly useful in industrial applications, where fullerenes can help create more efficient and environmentally friendly chemical processes. They can also be used to help purify water by trapping pollutants and heavy metals within their structure. Their large surface area allows them to absorb contaminants, making them effective in advanced filtration systems. This is important for providing cleaner water supplies and improving public health. In today's lesson, we delved into the structure of fullerenes, hollow, cage-like structures composed of carbon atoms in hexagonal rings. We discussed Buckminsterfullerene, C60, also known as a buckyball, and its specific structure of hexagons and pentagons. We then understood different uses of fullerenes because of their specific properties. Their hollowness means they can trap other molecules inside them, meaning they can be used to deliver drugs directly to targeted cells, such as cancer cells. Their large surface area, combined with their ability to bind and release various atoms and molecules, makes them excellent catalysts, speeding up chemical reactions. Their large surface area also allows them to absorb pollutants, making them effective in water filtration systems. Today, we have understood structural ingenuity and versatility of fullerenes, underscoring their importance in modern scientific and technological advancements.